Hello, everybody. Welcome again. And we have a few people. I think in our culture, it is okay. People come late to meetings. Yeah, but they're gonna to miss a good presentation from Axel Pavlik. He's here. He came a long. He had a long journey since yesterday to come here and give us some updates about Ripe Ncc.
So yes, I'll do that. Good morning. My name is Axel Pavlik. I'm the managing director of the Ripe Ncc. Well, yeah, I flew through the night, but that wasn't too bad. If I appear a little bit tired, then that's what I am. But I hear our colleagues from Yerevan came in a bus for 24 hours. That is more of an adventure. So, update from the Ripe Ncc. Maybe for those of you who are not that deeply familiar with us, what is the Ripe Ncc? It's the Secretariat for, it started as the Secretariat for the Ripe community at a time where Ripe was very much focused on Western Europe. But of course, we have grown, the service region has grown quite dramatically. So now it's it's Europe, the Middle East, and parts of Central Asia, as we say. The things that we do are quite varied. Now, the Secretariat for the Ripe Committee started as the place that was there to organize those smaller Ripe meetings with maybe 50 people coming or smaller before that. And at some point it became important to organize that a bit better to make sure that there is enough coffee and enough cookies there, and that we would have somebody to call in the office in between those meetings for coordination purposes. But relatively quickly, in '92, we were asked to also, as maybe an experiment, take over part of the global IP address and AS number distribution. That was until then all done centrally from California, and as the internet started to grow quite rapidly, folks thought it would be nice to have somebody else doing this. And from that, of course, the RIR system spread on all the continents, but we were the first ones there for Europe. We maintain the software for the RIPE database. That's something that we also do for a very long time. We have added some services basically around data, finding data, making data accessible, and generally we see ourselves as doing anything that is of use for our members and for our community, building tools that you would need, that you would find useful. Just talk to us and we might actually find the time to build them. A great thing, a great property of the Ripe Ncc is that it is entirely funded by members. So we are a membership association. We do what our members tell us, and of course we listen to the community as well, but we have some formal processes so the members get to say what we are doing. There's no string attached. We don't listen to anybody else. Well, we listen to lots of people, but there are no forces behind the scenes. The NCC strength is built on those principles of openness, of transparency. We are neutral between our members, looking that we treat them all the same and fairly, and impartially. So open, transparent, neutral, and impartial is a bit of the mantra for the Ripe Ncc principles there. Now, the world is an interesting place, more interesting daily. We have had a couple of meetings with our board looking at strategy and what we should be focusing on this year. So that meeting obviously was last year. We should rethink our service delivery, so the way we are dealing with our members, making sure that it's efficient and remains fair, while also looking at new developments to see where we can improve that service delivery. And of course, accuracy of the RIPE database and the registry, maybe more importantly. Giving out IP addresses and AS numbers is something that we take very, very seriously, and we run the registry, the regional internet registry for the region. So we keep track of who uses which addresses, and that is the registry, and we are fully in charge of that. The RIPE database is a little bit bigger than that, and there are our members who also fill in fields in the database, and that's something that is slightly outside of our direct influence. So accuracy of the database is important, and even more so of the registry. So outreach to stay connected with our members and other stakeholders. Hey, here we are. We do outreach a lot. We like doing it. We like going around meeting our members face to face at these kind of meetings, but also in trainings, and you've seen training courses earlier this week, member lunches, going to other events and turning up and finding our members there. So that's something that's very close to our hearts and very important, of course, also for us to understand what you want from us. Other stakeholders just as well. For many, many years we are talking to governments and regulators and police forces and people like that were not the original core of our community as in network operators. Strengthen the global area system and ensure that it remains accountable, transparent and resilient. Now there are 5 areas around the world of varying sizes, but basically all operating according to the same principles, all bottom-up industry self-regulation, all accountable, transparent and fairly stable with reserves and all that. But of course it's important that it remains like that. So, yeah, understand our members better to meet their needs and add value to the operations. I think that's something that's intrinsic in all of those points that I mentioned earlier, the services that we are doing. It's important that we understand our members and that we do something that helps you do your daily job and run your businesses. Right, members are important, and there are lots of them. It's quite not really scary, but it's very impressive how quickly the LIR count goes up. Now, there are members and there are local internet registries. A member can hold several local internet registries. The LIRs are the basis of our accounting, of our income. So we count them, and you see it goes up quite dramatically, more than, or nearly, we could even say 3,000 in a year's time. Wow. And of course that impacts the addresses, the IPv4 addresses that we have left. We do see the membership growth driven by the need to obtain the last /22 allocations per LIR. That's the last /8 policy that's in place for quite a while. The last /8 from that last /8, the 185 that we received from IANA many years ago already, we expect, that's gone, that's completely gone. But of course we have received some address spaces back, some blocks back over the last couple of years, being very careful that we go out to our members and to pockets of the community where we expected that there are unused addresses, and we did get quite a good number back. So we expect that we will be able to run this last /8 policy for maybe about 2 years. Okay, so there are not that many fresh IPv4 addresses available, just tiny blocks, but there's still need. People haven't completely switched over to IPv6. So yeah, we see lots of transfers between parties within our service region, also within the RIPE region and the ARIN region and the APNIC region. So there are lots of transfers going on, and you see a very sharp uptick there in 2017. Generally, you saw that the trend was sort of maybe going down since 2014, but yeah, 2017 was a bit crazy. And we think we have figured out what it was. We think that nearly 80% of those 21 million were administrative transfers between within one company group, between businesses belonging to one company group, and then what comes to mind is, oh, there might have been quite a number of businesses going for the last /22s, and then they might have been merged, and maybe that's what we are seeing here. The remaining, not quite 5 million addresses, were between unrelated businesses on the market, and then 5 million, if you look at that, that's sort of there, that is continuing the trend that we've seen before, the downwards trend there. Overall, the number of individual transfers, we were looking at the number of addresses here, but the overall number of transfers has also gone up quite dramatically with smaller blocks there as well. So that's more work for us, lots of looking at who is doing what and scrutinizing applications and those transfers, seeing that they all go according to the policies. An interesting thing that we are seeing here is that we have more LIRs, again, since a while ago, without IPv6. For a while, of course, we were tracking IPv6, and more of our members had IPv6, and that is, of course, still the case, but there are more without. There's a trend there, but we are not overly alarmed by that. We see that with the last /22 from the V4 blocks, we removed or the community policies removed the requirement to also get a V6 block with that. So that's what we are seeing here. There are more LIRs for the last /22, and they, in many cases, don't need V6. Right, I mentioned the Ripe Ncc is a membership association. It belongs to the members run it. So it is important that you pay attention, if you're a member, to those general meetings. We have 2 of them in the year, one at the Ripe meeting towards October, typically, and the next one is coming up in May at the next Ripe meeting in 3 weeks' time. And the interesting thing here is that we have 2 board seats that are up for elections. 2 of our board members expire. So here we have like 6, right? 6 new candidates that are confirmed. So there are democratic elections. That's interesting. Please take part in that. We also have a vote on the charging scheme for next year. We don't foresee any changes there. It'll be the same. We propose the same as for this year. It's nice and stable. The financial report, again, the formalities of the corporation, of the membership association need to be done properly. So we have published a financial report, and the members are hopefully looking at that, and they are already asking some questions, but the idea is that they would adopt that in May. We also have arbiters, an arbiter pool, in case a conflict arises between members or between members and the Ripe Ncc. Like I said earlier, we want to be neutral between those members, among those members, how we treat them. So for a very long time, we have an arbiter board, people that look at conflicts and decide who was in the right and who maybe was not in the right. So in the early years, there was not that much activity, but as we see transfers, as IPv4 addresses seem to have acquired some value, you can imagine there's more going on there. It's not a lot still, but it's a steady trickle of little cases there. So we had a good number of auditors, but they sort of faded away over time, not all of them, but a couple of them. So our board says, hey guys, it's time that we replenish the board so that we have enough arbiters there. Also people can choose from them then a bit. And there's one from Iran as well. That's nice to see. And the other thing that my board, especially the guy that has a house in the Netherlands, the treasurer, is always after is that the board is again formally discharged for all the activities they've done over the previous year. So that's something that's formalistic but needs to be done. It's a good thing and happens at the general meeting. So if you want to vote and if you're a member, I can only encourage you to do that. Please do register. Also, for many years now, we have the ability to remotely participate. We have a very wide service region. So what we typically do is we run the bones of the meeting on one day and then leave the voting open during the night so that all the far outlying ends of our service region have the opportunity to vote within their business hours, their convenient hours. All right, yes. Speaking about formalistic things, you might have heard about the GDPR, the EU General Data Protection Regulation. It's a big thing. It comes into force, oh my God, next week. Not next week, but later in May of this year. It sort of crept up, apparently, on a lot of people. And suddenly there's a flurry of activity, and everybody needs to get their data protection procedures into place. And, well, we have looked at what we are doing in terms of data protection many, many years ago already, and looking at it again now and making some adjustments and rethinking things, we see that we are positioned quite well. Now, we've conducted the internal review, so it's still going on, but the main things that have been done to ensure that we are fully compliant to the degree we understand the directive. And that's the interesting thing that many people are saying, also within the EU. Oh, this is a new thing. They don't quite understand themselves the details of how it will be applied and how the fines will be done. So we see there is no reason for panic with the Ripe Ncc. We have done our stuff many years ago. We have checked it again. We are compliant. It's looking good. Right, and there's a couple of articles on Ripe Labs if you want to read up on that. And I'll go on. So, like I said, the Ripe Ncc is there to do all sorts of things that our members and the community wants us to do. We have seen that the Internet of Things is in the press quite a lot over the last years. It's sort of a big new thing. And we scratched our heads a little and said, what is that? Is that something for us? Is it something that we should be working on, working with, following, or being more pushy? We've seen a couple of really big distributed denial of service attacks there, sort of through the IoT. So you're thinking, oh, our members, network operators, they will possibly be under pressure there. So with those things, we wondered. So what we've done for a couple of Ripe meetings already is run small birds of a feather meetings, smaller rooms, a couple of people interested in IoT came together, and it turned out that, oh, the small rooms were occasionally very, very full. There is quite a lot of interest in our community on those things. So at the last Ripe meeting, it was decided to have a working group on IoT at Ripe meetings. And I'm very, very glad, because from that working group, I'll get my input on what I should tell my staff at the Ripe Ncc, what our role is in the IoT field. So yeah, we have a working group there. Good, capacity building, training and the like, and that in Iran. First of all, I didn't say that as I started, I'm very glad to be back here again. It was a very long 4 years since I was here last time in this room, even. It looks all very familiar. So I'm glad to be here. But of course, it's not only me. We have lots of people working for the Ripe Ncc and working for the community within the Ripe Ncc and around the Ripe Ncc. So Train the Trainer was a thing that we did last year. We did a member lunch. I mentioned those member lunches earlier. When there's an event in a city, we, in many, many cases, call up the local members and said, hey, there's lunch, we're in town, do you want to come? A workshop for law enforcement also in 2015. Then that was the other meeting that I was mentioning 4 years ago, that we came for the first time to Tehran. And of course, ongoing training courses all the time. So glad to be back here again. Yes, also somebody that we are closely following and that we are supporting are the national operators groups, saying the RIPE community basically was a small European set of network operators. So those guys, network operator groups, are our core community in a way. And it's great to see that so many of them in our region have sprung up, and we try to foster them when we go to a place, for instance, where they are not existing yet, where people are coming together. We ask them, is there something there like that? Is that something that you would be interested in? These are our experiences with them, so we can help with experience, what we've seen in other places. We can make connections. They're connecting people. We can provide speakers for events, do a little bit of moderate sponsorship there, and yeah, basically talking about what we have been done for the last 30 years. I see that the local Iranian NOG has recently been formed. I think we'll hear about that a bit as well. But also, there should be a link somewhere there. There. We have a new section on NOGs on the RIPE Labs, and there is a nice article on the Iran NOG that I recently read. So it's an inspiring story there as well. There's a map with probably all known NOGs in the world. You can drag the map around and zoom in and out. We surveyed them and basically looked at how they are structured and what their local approaches, and have a survey there as well, the outcome. So the goals there is, like I said, connect people, support the local and the regional relationships of the operators, engage with our members and our community more effectively throughout our big service region. We think operators, operating groups have a crucial role there to play in the development of the net, and of course we support that. It's our, like I said, core community. Good. The RIPE Ncc gives out internet addresses and AS numbers according to policies. Well, rules, really. Some people get nervous when we say policy, but it's basically, we call them policies. We have the policy development process, and we have currently a couple of things under discussion. The first one is maybe the most interesting one on the slide, is the regular abusee validation that's ongoing since early last year. It's one that has been brought on by the law enforcement community. First time that they did something like that in the policy development process. The idea is to give us the mandate to check regularly the abuse contact information in the database and to follow up and poke people when we see that the information is not there or is invalid. It's quite an interesting discussion. There are very many also quite opposing and heartfelt opinions there. So it makes for good reading if you haven't read the mail thread there. Then we have ongoing little housekeeping policy changes, where we said on the next one to request IPv6 per organization. That has been changed now. We're like, what is an organization? What do we mean? Just streamlining the wording there. And that's now per LIR. Similarly, clarifying the definition of assignments in the IPv6 policies. It's small and simple things, but needs to be done to make the documents better. Training is a big thing, as you know, as you are here. We see that trainings are extremely popular, and we would like to go out and do face-to-face trainings all the time, but that is nearly impossible. That is impossible because they are so popular. We have a limited amount of staff. So at some point we said we also want to do remote training, have material available, try different approaches. So webinars. We have webinars on internet routing registry, on RIPE Atlas, on database, on IPv6, on internet governance in general, and the key signing key rollover in the root server system. So a rather wide variety of topics from very high level to quite geeky. Have a look. It's interesting stuff. Occasionally we are told to be treading very lightly in the office, because we don't want to disturb the webinars that are running, possibly. Similarly here, Educa is a new thing, Ripe Ncc Educa, where we basically run a full day event with our own staff, but also with external experts on a specific topic. So that's, like I said, it's a relatively new thing. We have done one in April this year. This done, right? I think yes. On routing security. The next one will in June will focus on IPv6. So we expect quite a high number of people to come to those remotely. They have been quite successful so far. Please, if you are interested, have a look and let us know what you think of them. Yet another thing is the Ripe Ncc Academy. It's a virtual learning environment. It is becoming a little bit more formal here. The goal is to get qualified for various topics, like again LIR topics, the database expert, introduction to IPv6. They are available to members and also to just community members, not Ripe Ncc members only. And the idea is to get certified properly through the academy. We are having a couple of very neat ideas there, but they're not quite done yet. So you'll see developments in the near future. Community building is something that we are gladly doing. We have a couple of initiatives there and ways we are doing this. So the Ripe Academic Cooperation Initiative, RACI, is one, where we invite young researchers, scientists from the academic community, obviously, to come to Ripe meetings and related meetings and to present on their work. And yeah, that's very popular. It works quite well. I think we get new people into the community that way. Ripe and also MENOG fellowships, similarly helping people attend the meetings, coming to them where maybe they are not able regularly. So tickets, travel, accommodation is paid for. All attendants can publish the work on Ripe Labs. And yeah, there's a link to the application forms and more information. So my time is about up. The next Ripe meeting is coming up in Marseille, southern France, in May. That should be rather nice. Of course, you're all very much invited to attend in person. I think it'll be a really nice meeting. If you can't make it because you are really having to work at home, then remote participation is, of course, possible as well. And I would invite you to ask me any questions. I don't know whether I could answer them, but I will find somebody to answer them for you, if it's not me. Yes. We might need help with the microphone.
Good morning, everyone. My name is Arash Nadepur from Parson Network Solution. My question is about the way that Ripe Ncc is treating the members. Is it really, I mean, do you believe that Ripe Ncc is treating the members equally?
That is a good question. We strive to do that. We are having ideas that we are looking at around what we call internally sort of a professional trust model. As you observe what is happening, basically, yes, members, yes, we treat them equally. We have always done that, and we do that to the best of our ability. Then you see what's happening over the last couple of years around transfers, around scarce resources. You see quite a number of shady things happening that are clearly not in the spirit of the policy, but maybe not technically wrong. But also there's fraud going on. We see falsified passports, we see very shady documentation or no documentation. And as you say, we in principle want to treat people equally, but also fairly. And now we are looking at ways at distinguishing between good members of the community and people that we have had other experiences with. But I mean, that's something that will continually report about what we are doing there. We haven't started anything.
Okay, my next question is that, do you need any more resources to do that in a better way?
Yes. Now, that's an interesting question. Like I said, we are running out of IPv4, and we thought for a long time, oh, then work will go down as well at some point. Now, we haven't quite run out yet, and what we see now is, at this stage at least, the work is more. We do regular allocations, but also the amount of checking we have to do to see that everything is above board and properly done is quite dramatic. So for the foreseeable future, I think there will be quite a lot of work. And we could, of course, use more resources, but on the other hand, we don't want to grow to a behemoth of 500 staff. We currently be 150 roughly, and I think that's a good size. We need to work efficiently and effectively.
Okay, my last question is that if Ripe Ncc is a membership-based company, right? So if there's a kind of situation that Ncc needs to decide if it protecting itself, or members' benefit, what would be the choice?
That is another interesting. You have good questions. I like them. So the Ripe Ncc is there to serve its members.
Yep.
I have gone on record many times saying, if the members don't need the Ripe Ncc, we can go away. But okay, that's an extreme case. There is work that needs to be done. The registry needs to be maintained, certainly. If you should get into a conflict between what's good for the member maybe, and what's good for the Ripe Ncc, I hope that we would find a way to say what's good for the member is also good for the Ripe Ncc, because membership support carries us, right?
Yep.
Then if we have a real conflict, we have the arbiters board, where we can refer cases to, or the member can go to the arbiters board and say, hey, I have an issue with the Ripe Ncc. I think they are unfairly treating us. Can you please help me? Can you judge properly?
But that's for the time that there's a case between Ncc.
Yes.
But I'm talking about something more general, like a group of members benefit or new members benefit, and Ripe Ncc protecting Ripe Ncc legally. I can give you an example.
Yes, please.
Yeah, for example, the standard service agreement that you send to the new members, and they need to sign it to become a member.
Yeah.
What you're sending out now is in English. And all new members, the ones that are really need to become a member to just get some resources, they're not really interested in Ripe or Ripe Ncc. They are directed by their service providers to sign up and receive some resources to get the job done. That's all. They have to sign a service agreement with Ncc, and they don't have any clue what they are signing, because it's purely in English, and many of these organizations are not really can understand that service agreement. And they're not providing them anything else, like a translation to their own language, even an official translation. So they are signing something blindly that they are not aware of. And based on that, they have a kind of legal liability to do some certain things. And they cannot do that because they're not aware of that. So we see that the database is not really updated because the end user is not aware of the policy, what the policy is asking them to do. They just receive their yearly invoices and they pay that. They ignore all the emails that you send to them or member discussions. That's a good example, I think.
Good. That is a good example, indeed. We have had similar discussions for the last 20 years, I think. And I appreciate your input and your feedback there. And I think that is something that, now I have to be careful with what I'm saying because it's work. but certainly something like a informative translation should be possible, where protecting the Ripe Ncc, saying the legally binding text is the English text, but to the best of our ability, this is the local language equivalent of it. I think that's something that we should look into.
But you had this discussion since past 20 years and we're still receiving the English version, right?
Yeah. It's somewhat unfair, I see that.
Okay, that's the one thing that I want to hear.
It's somewhat unfair. It's great for the Americans, and it's great for the English, and it's great for many other people. For some countries where English is not spoken a lot, it's awkward and it's not convenient. We see, and I would encourage the local community, that's always nice to have a local community that can look at texts and try to translate them if they have the time and the resources available of certain parts of our website, policy documents and the like.
But if they do that, it's something like locally available to the community, not through the Ripe Ncc. So when a new member wants to join, they need to receive that from the Ripe Ncc because the local community is not aware of the new member.
Oh, right. Things like that can be done. I mean, we connect people. That's part of our idea. So of course we can on our website point in our communications on paper or however we communicate with the new members can point at local resources as well, if we know they are there. So then I would invite you to make those things available and known to us. The reason we have been reluctant in the past and are still somewhat reluctant is it's of course a lot of work to do this ourselves, and we can't. We speak a lot of languages but not equally well. And cross-checking, quality checking is something that is very hard for us. So we have shied away from generally lots of translations.
Yeah, that's why I ask if you need more resources to do that. Yeah. And
you see, it's easy to say, yeah, let's do all. We have 76 countries, I think. Let's do all languages in those countries, and there'll be a lot of work.
Yeah, but you have like 18,000.
Sure.
Oh, sorry for that. Yeah.
Yes.
Yeah.
I can take. Because we ran out of time.
But okay, no worries. Yeah.
But we can also take it offline, of course, and continue.
Thank
talking.
you.
Thank you very much.
Hi everyone, good morning. My name is Milad from Tech. I'm not going to ask a question exactly because you mentioned about NOG's in your presentation. I would like to say thank you on behalf of our NOG community for supporting us to setting up our first NOG in Iran. And just this, thank you very much for your support.
Thank you very much. Good to see you.
Hello. First of all, I want to say thank you for being in the community and for responsibility. I have a question. My memory is weak, but as far as I know that most of the Ripe Ncc members have the less IP addresses in terms of the number of the IP addresses, if I remember correctly.
There is a public list which address blocks
Yes.
are held by which members. Yes.
Yes. And in the payment policy of the RIPE, which I remember 8 years ago has been accepted, the payment is equal right now. I want to continue Arash's question. I want to, you say as the CEO of the Ripe Ncc, maybe there is a shortcut that the community isn't aware, or maybe something that we are not aware. Please clarify this for us, that what is the problem for the community to create a policy, create a new policy to be back those days for 10 years ago. Myself, in those days, one of the things that I didn't start to got the new IPs was that policy. You know,
Yeah.
if I get new IPs, I should pay more.
Yes.
You know, I think one of the problems in IP market is this policy right now. Most of the members may have benefit for that policy. So what's the problem?
There is no problem. So basically, you're asking about the charging fee,
Yeah.
right? So we did have a charging scheme that was elaborate and somewhat complicated and also somewhat academic. But basically, the fact was that members who held lots of address space paid more than people who held little. There were grumblings at the time, and we thought, what could we do in a different charging scheme that would be fair? And the outcome, we had a whole charging scheme task force around that, members of the community debating for months. And the outcome that was accepted was, it would be, from the philosophy, okay, so we run out of IPv4 at some point, and yeah, you might have lots or smaller holdings. It's not really relevant. It'll all switch to IPv6, and then it's huge amounts anyway. So let's ignore that for a while. The Ripe Ncc is not only the registry, it's also a membership association that does things that are good for the community. And in a way, it's a club. And if you want to be a member of that club and participate in what the club is doing, also benefit from some of the services, some of the trainings, it might be nice to pay a simple fee. And that was accepted at the time. It doesn't have to be like that forever. If you look at the other RARs, they have not yet that simple charging scheme. They have variations, but it's also complicated. And I just had been at an Erin meeting. They are looking at that, and they're increasing some fees here, and then the smaller members. It's complicated. And we were at the time, and are still very much in love with the simplicity of this. Also internally, it's very efficient. The same bill for everybody without complicated calculations. But it can be changed. We have had a bit of discussion at the last general meeting, I think, where people said what you are saying. We had a discussion again on the mailing list before that, but there was no clear consensus. So our board says the biggest consensus that we see is continue doing the old stuff. But if you get a group together, and I mean, the mailing lists are open, go and argue for it. I realize the strange thing currently is, now we have the proposal for a new charging scheme for next year, and if that is not accepted, we will fall back to the old charging scheme. Happens to be the same. So formally at this general meeting, you don't really have a choice between different charging schemes. I did talk to Serge at home, one of our comms person, and he brought that up. So I'm open to thinking on how we can change.
Yeah, I think we'd better to follow these discussions up on the mailing list.
Absolutely.
And we have plenty of mailing lists about that, and there's a link queue.
Okay, my last question is, as one of the biggest community as an Iranian, can you, as Ripe Ncc, create a simplest method for paying, about sanctions? I want to say, is it possible to, for example, Ripe Ncc create an organization inside Iran that we can pay in Iranian reals, for example, something like that?
I know there is a problem, and I want to help solve it. We have a new chief financial officer in the company. Let's talk about what we can do. I don't know whether that is a viable way, but obviously
possible?
we want to help you.
Is it possible at all?
I don't know. I think it's possible to set up an organization here, but then how do we get the money out of the country, right? It's sort of a similar problem.
Okay, thank
but
you.
I know there's a problem there.
Thank you.
A small addition.
Short, yeah.
Very small addition. Van Hofsepan, Ripe Ncc, External Relations Officer for Central Asia and Caucasus. So actually, coming to the issue of local support to the languages, etc., etc., Ripe Ncc is not only the organization in Amsterdam. Actually, we have a lot of teams, dedicated regional office in Dubai with dedicated external relations officers. We have not only external relations, but also people working with academic engagement, with policy, etc., etc. And they are all ready to support you with any question. Even if it is in English, if you don't understand something, if you need something for your community in your language, we will find a way to support you. Just ask us the questions, and definitely Ripe Ncc, 99.9% will be supportive to you. Thank you.
Thank you.
Thanks, Van.
And thank you, Axel. We were very happy to have you on board. Thank
Thank you very much for the questions.
Quickly, our next speaker is Philip Pops. He will talk about FreeBSD.
The resolution is fine. That should be fine. Okay, this is a clicker thing, and there's a laser pointer there as well. Oh, right, so good. So I can point to right. I can point at things. I think you've got the slides reversed. Try. The screens are. Merge screens. Somehow the button here. Sorry. There we go. Cool. Perfect. And now that one and that one. Oh, the two side displays are now. All right. Will they come back? This is the same problem as yesterday. So what they're. Is the microphone on? Hello. Happily, my slides are not very interesting. I'm a lot more interesting than my slides, so you'll just have to listen to me instead of watching the projector. So, good morning, everyone. Salam. My name is Philip Paps. I wear many hats, but the hat I'm wearing today is my FreeBSD Foundation hat. I'm not a network operator. I'm an operating system hacker. I do a lot of work on mostly low-level software, device drivers, bootloaders, and that kind of thing. But I've also got a soft spot for the domain name system since someone asked me several years ago to teach it at a network operator group, and I've not been able to escape since then. So another thing I care about deeply is, well, I care about the environment as well. So this presentation actually combines a couple of things I care about. It combines the domain name system, it combines the FreeBSD operating system, and it has a little bit of environmental information. So let's talk about the domain name system, the DNS. The data I've got for this presentation comes from the DK domain from Denmark. Denmark is a small country in the frozen wastelands of Northern Europe. But the reason I've been using their data is, well, firstly, I've got their data. And secondly, they are a small country with a DNS zone that's roughly representative for most CCTLDs. So some countries with larger populations will have larger DNS zones, but it's about average size for a CCTLD. This is traffic as of December 2016. I hope it's legible, but I'll go through it very quickly. There we go. The DK zone serving the authoritative servers for the DK zone have a bunch of authoritative unicast servers, which each serve about 1,000 queries per second. So compared to, say, the root servers or GTLD servers, this is statistical noise, right? The DK zone has about 1.3 million domain names, which for a country with about 6 million people, last time I checked, is about 1 domain name for every 6 people. The interesting thing is that 11,000 of these 1.3 million zones are DNSSEC signed, and this obviously affects the size of the zone file. So if you've only got NS records and a bit of glue in your zone file, the zone file is really tiny. But when you start adding DNSSEC signatures, the zone size really increases. So the total zone size for the DK zone is about 190 megabytes as of December 2016. That's probably just over 200 megabytes now. And depending on the name server being in use to the individual, they run a mix of binds, NOT, and NSD. And depending on which implementation they use, it's about a gigabyte of memory. So that's, again, in the greater scheme of things, a gigabyte of memory is statistical noise. It's not a lot of data. And the CPU load of their authoritative servers is approximately 0. So these servers are just sitting there in a rack warming up the room in the steady state. They only actually do anything when they are loading the zone file, which happens pretty often, especially with DNSSEC. You have to keep refreshing your signatures, so the zone file gets loaded from time to time. And each of these servers has about 10 megabits per second of continuous traffic, which, again, is not a huge amount of traffic. So let's talk a bit about their operational structures. They've got 4 unicast servers, some of them inside the country, 1 or 2 of them outside the country. I can't remember. It's been a while since I wrote these slides. So it's a pretty similar setup to other CCTLDs. They've also got 7 Anycast clouds, and in total they have about 120 nodes serving their zone file. What do they run this on? They run this on off-the-shelf Intel servers. So they go to Dell or Supermicro or HP. They say buy now, and they buy a server. It comes in a box. They put it in a rack. They deploy it. They put FreeBSD on it, of course, because what else would you run on a server? And on average, all of these servers have a resource utilization of between 2 and 5%. So that's taken over a long period of time. The machine boots, you load your zone file, the DNS serves its data, someone goes and changes a DS record, someone adds a new domain names expire. Roughly, the resource utilization of every individual server is between 2 and 5%. So what's happening to the other 95 or 98% of resources? They're just sitting there idle, and they are warming up the data center for no really good reason. So I'll talk a little bit about better ways of using these resources, or getting better resources for the task at hand. So in this presentation, when I talk about network servers, I mean servers that provide network support. So things like DNS or authentication or LDAP directory servers, not servers like web servers or video servers, because those obviously need to be beefy and they are going to run at 80% or 90% of their capacity. Whereas network servers are things you need in your network. They need to be reliable, but they're going to run at maybe 2% or 5% of resource utilization because the things they do are really trivial. So what do these network servers care about? They care about CPUs more than anything else. So what you find with network server workloads as compared to content server workloads is that the The workload is mostly CPU bound. It's not network bound, it's not I/O bound, it's just the CPU doing many, many trivial things all at the same time. This is in contrast with, say, a video server, which needs to load data from disks and put them back on disks and then push it out, and it's a lot of memory churn. On network servers, it's mostly CPU bound. Network servers care a little bit about memory and bus bandwidth. Somehow you need to get the data to the CPU, otherwise there's nothing, nothing for the CPU to do. Thirdly, a network server cares about the network because it's a network server. Eventually, the data needs to get into the network. And finally, at the very lowest priority, these things care about disk I/O. As we'll see, the data a network server deals with usually fits in memory. So disk I/O is a one-time thing. The system boots, everything is in memory, and it never touches the disk again. So this is an ordered list of resources network servers care about. They care primarily about CPUs. Can you do many things at the same time? They care about memory, keep the CPU busy, and network, push bits out to the internet, but they don't care a lot about disk I/O. So there have been a couple of attempts in the past at making CPUs that are good for these sort of workloads. I don't know if anyone remembers the Spark v9 made by Sun. Sun is now dead, but that was a gigantic failure. It was a very power-hungry CPU, and it was not very successful at all. Caveum made a pretty successful MIPS implementation. It's very popular with embedded routers. Your internet edge router devices have these things. And MIPS is really good as an architecture for network things because it's big endian. Then there was a nice spirited attempt by a company that's now known as MENOG, but their CPU it's very low power, but it's not very good at that memory handling. So that's mostly gone into very deeply embedded things now. And then finally, you have two CPUs which everyone hopefully recognizes. You have the Intel Atom, which was a very popular CPU. Unfortunately, it was really slow, and you only had a couple of cores you could handle realistically on this architecture. And finally, you have the 32-bit ARM implementation, which is everywhere. Well, these days, it's ARM64, but everyone's phone, until a couple of years ago, had an ARM v7 in it, which is a low-power CPU. It's pretty good at doing trivial things in parallel on multiple cores. It can keep memory busy, and it's not very good at disks, but it doesn't have to be. So if I can find my mouse pointer, there we go. So let's talk about what this presentation is actually about. It's about the ARM64 architecture, which is a new attempt at a server-grade architecture. The ARM64 architecture is also everywhere in everyone's phone. I think there are more ARM64 cores in this room than there are Intel cores. Everyone who has a phone in their pocket has at least one ARM64 CPU in their pocket, probably anywhere between 6 and 8 of these cores. So they're very popular in phones, but they also work really well for servers because many of the useful properties phones rely on are also valid for network servers. So the ARM64 architecture is formally called ARM v8. It's the 8th attempt or the 8th upgrade of the original Acorn RISC machine from the early 90s. It's a completely 64-bit instruction sets architecture, and it's an upgrade of the 32-bit ARM architecture. It's got a number of nice features for people who run servers. So it's got AES instructions in hardware, which are very similar to the AES native instructions you find in Intel CPUs. And the performance is also very similar. On FreeBSD, we get 2 gigs in block mode per second out of the hardware. So that can keep a gigabit network interface saturated very easily. If you've got a bunch of cores and you can do things in parallel, you can keep your network string pretty much saturated easily. The ARM64 architecture also has standardized on-core peripherals, much like the Intel architecture. So things like message signal interrupts and IOMMU behave very similar to the ones on Intel architecture. So they're very easy to support for those of us who work on operating systems. Another thing that is nice for operating system developers and also vendors of servers is that the ARM64 architecture is a lot more like the Intel architecture in that there's been an attempt at creating unified configuration mechanisms. So on Intel, historically you have the BIOS, and more recently you have ACPI, and even more recently you have UEFI, which I think is a crime against humanity, but I'm not allowed to say that out loud. Oh no, oops. So on ARM, on ARM64, you have the same thing. We don't have ACPI, thank goodness, or not in the same shape we have it on Intel, but we do have UEFI. So the things that operating systems developers are familiar with on Intel just port neatly to ARM64. There's no new things to do, just like on ARM32, where every platform you had to go and write a new device driver for everything because things were connected in random ways. On ARM64, it's a lot more like the Intel world. The device is self-describing, and the operating system can just cope with it. And the good news for everyone in this room who does not work on operating systems is that all the standard peripherals like disks and network cards and non-volatile memory works exactly the same way as it does on Intel. So if you've spent several $1,000s on 10 gigabit Ethernet PCI cards, you can plug them into your ARM64 server and they will just work. This is not the case for ARM32 or for any of the other exotic platforms I described earlier, because there's just no physical slot for you to plug these things into. On ARM64, you can just plug these things in. I've looked at some commercial off-the-shelf hardware. Yes, it exists. I've looked at two platforms. I've looked at a big platform and I've looked at a little platform. So the big platform is massively overspec'd for any reasonable network use, and the little platform will probably perform well, but you'll need more than one of them. So the massive platform I've looked at is the Caveum Thunder X. It's got 48 cores in the basic package. It's got 96 cores in the last time I checked, the biggest one they would sell to you. 16 PCI Express 3-lane slots, and it's got 3 40 gigabit Ethernet cards or 40 gigabit Ethernet ports, or 12 10 gigabit Ethernet slots, and you can program the queues. So this is a massively parallel, powerful beast of a CPU, which is it's overspec. You don't want one of these. The server boards you plug this thing into will set you back about $3,000. So that's just the motherboards, and it will have one of these CPUs. It can give you 8 gigabytes of memory, and you've got some 40 gigabit Ethernet and some storage. So this is a pretty expensive piece of kit, but $3,000 is probably what people spend on DNS servers. Let's look at a slightly cheaper one, or a much cheaper one, is AMD makes one of these CPUs as well. They've got something called the A57, which, I've lost how fast it was. I think the maximum it has is 12 cores, and most implementations you'll find is between 4 and 8 cores. So the one board I found from SoftIron costs about $600, which is a lot cheaper than what most people would expect for a server. So that's just the board. So if you want a server with this, you'll have to add a power supply and a box and a support contract, and it'll probably be about $1,000, but it's still a lot cheaper than the $3,000 to $5,000 you'd spend on a DNS server otherwise. It's only got a gigabit of Ethernet and 8 gigs of memory, but it's got a 1 terabyte hard disk. So if you remember the .dk DNS zone, it's 1 gigabyte of data in memory, so it would still fit in here 8 times, and it's 10 megabits per second continuous traffic, and this one has got a gigabit port. So all other things aside, if you just want to serve DNS and you never need to reload your zone file, this machine could serve it pretty well. Of course, you need to reload your zone file from time to time, and there are other things running than just pushing DNS packets on the wire, but something closer to this end of the spectrum rather than the other end of the spectrum will work pretty well for your DNS server. So let's look at some of the nice things about ARM64. The platform, if you've not heard of it, is fully supported on FreeBSD. It's probably also supported on other operating systems, but who cares about those? With fully supported, we mean it gets security updates and it has all the third-party packages available. So you can just install it out of the box from a memory stick or a DVD image or whatever medium you like. You install it and you get full support from the FreeBSD security team. You run FreeBSD update, you get all your security updates. You want to install your DNS server, bind, NSD, not, whatever. You can just do package install named, package install not, package install NSD, and it will just work. And the next version of bind that comes out, or the next version of NSD that comes out, you just do your normal systems administrator procedures, you keep it up to date, and it will just work. DNS on FreeBSD on ARM64 specifically is well supported. On FreeBSD, we support all the common authoritative and recursive DNS implementations, and mostly they're supported and maintained by the people who work on the actual DNS implementation. So our bind maintainer, our NSD maintainer, and our not maintainer, and our power DNS maintainer are actually the people who work for the companies or the organizations or the projects that implement these servers. So we have direct vendor support for all these packages. So FreeBSD is nothing to be afraid of. It has nice things. And ARM64 is nothing to be afraid of. It is fully supported and it just works out of the box. So let's do a little price and performance comparison with off-the-shelf Intel machines. If you get an Intel Xeon box, you go to Supermicro, you ask them for a machine, it'll cost you $3,000 and you get a bunch of cores and a huge amount of memory. A similar machine from Caveum will cost you about the same, and I've done a really pessimal workload on it. I've built LLVM, which is a compiler, and okay, it took 32 minutes on Intel. It took 32 minutes on ARM rather, which is a lot of time, and it only took 10 minutes on Intel. So you say, okay, fine, Philip, what are you talking about? This machine is the same price. It's 3 times slower, but you've just told me it's a lot faster. So what's going on here? I'm told I need to speed up, so I'm going to speed up a little bit. The LLVM workload is very, very different from DNS workloads. So an LLVM build is lots of continuous disk I/O. As I said earlier, a DNS workload has no disk I/O. You load the zone file once, it lives in memory, you never touch the disk again. The LLVM build spends a lot of time going in and out of memory, so it's just hammering the memory continuously. It's hammering the disk. It's doing things which a DNS server is never, ever going to do. And finally, the way LLVM is built is very difficult to run in parallel. You can only run it on one core, and it's just going to keep that one core very busy. Whereas DNS, you've got a zone file, it just needs to answer thousands of queries at a time, and just load a packet, find the response, put it in a packet, send it off on the wire. It can do all of that in parallel very easily, unlike the LLVM workload. And then let's look at the power budget of these things. Your traditional x86 server is very warm. The Haswell CPU has 135 watts thermal dissipation on idle and 250 watts under load. The ARM64 one is 120 watts and only 200 watts under load. And as this is the Thunder X board, the one you don't need. The lower spec boards run a lot cooler. I'm from the frozen wastelands of Northern Europe. Cooling your data center in summer is a matter of opening the window. And in winter it's opening a window. In summer you open all the windows. In places like Iran or warmer places, cooling your data center is a little bit more involved than opening the window. So saving 50 watts under peak loads and probably a lot more under realistic loads is going to save you a lot of money on data center cooling, and it's also going to save you a lot of money on hardware, so you win twice. Let's not talk about security because I don't have time. The conclusion of this presentation before Shaheen kicks me off stage, and we are running slightly late, and I'll give you a few minutes for questions, is if you are running network servers doing things like DNS or directory services like LDAP or authorization like Kerberos, or anything that spends most of its time CPU bound rather than memory bound or disk bound, you should definitely consider looking at ARM64 rather than spending a lot of money on Intel servers. If you are currently spending, say, $3,000 on a DNS server, or between $3,000 and $5,000 on a DNS server, you can probably get a machine that is much more powerful, or even more powerful, for the same price. And you can get a machine whose performance is closer to what you actually need for half the price. And in addition to paying half for your server, you're also going to save the environment and your wallet a second time on saving on data center cooling. Instead of having 200 watts of a machine warming up your data center, you might have 100 watts of actual, performance out of your machine. And ARM64 is really nothing to be afraid of. You can just run FreeBSD on it, and it will just work. And I think that is all I have time for.
Thank you very much. And any questions?
Yes.
Please,
in
short.
In theory, I have
really
7 minutes per question. In practice, I think Shaheen will kick us out in 2 minutes.
Yeah, sure.
So be brief.
You're the man for FreeBSD, so
Yes,
I have this question. Do you know if FreeBSD, we can run it on the tile processors or not?
On the who process?
Tile. Are you aware of them?
I don't think so. Maybe Tide?
Tile.
Tide.
T-I-L-E.
Tile, used for MikroTik routers.
MikroTik routers there, but MikroTik routers run MIPS.
Yeah, there's a new generation that is running based on tile processors.
I have never heard of them, but I think they are just MIPS, so they should just work. But I'm being recorded, so I should say, if that is not true, don't shoot me.
Okay, so there's no point to ask the second question, because I was thinking to ask you if you had any comparison between the tile processors and ARM64.
I don't, but I think the tile processor, I need to go and check, and you can ask me again in the coffee break, but I think it's a MIPS implementation. The MIPS will be slower than the ARM64 on most workloads because reasons. But what makes ARM64 fast is that you can stick tens or dozens of cores into a single package and run them in parallel. With MIPS, you can do maybe 4 or 8 cores.
Yep. Okay.
All right.
Yeah, we sit and have a
we'll
coffee
talk in the coffee break.
Yeah, sure.
Yes. Next question. Please remember to say who you are.
Babak Farouki from Immune Paris Technologies, and at the same time from FreeBSD project. So basically, there's a quick thanks because FreeBSD is not very well known in this area of world, and also the same goes for ARM64 architecture. So basically, people are going by default to get some Intel servers and run Linux or Ubuntu on it. So actually, the question is regarding the first part of your project about the .dk-ccTLD. I had the chance to speak with people from around the world running different ccTLDs, and it's from what I learned, they were mostly running CentOS Linux or different distros of Linux and running the same version of bind on all of their servers, which all know is not the best practice, but is unfortunately a common practice. So I was wondering if you have any statistics, if people are running other operating systems or maybe hopefully a combination of operating systems and DNS softwares around the world?
Yes. So the good news is that your own ccTLD.ir, I don't see Alireza anywhere, but .ir runs on FreeBSD or largely on FreeBSD, so that should make you feel good about things. Yes, there is a trend towards CentOS in DNS land, but there are still a lot of ccTLDs running on FreeBSD as well. Many of the root servers also run on FreeBSD. And many of the ccTLDs have a policy of running a mix of things, both of operating systems and of DNS implementations. So I've not actually asked if the .dk people run different operating systems, but I know they run different DNS implementations. They run NSD, bind, and not. And so I don't know if they run Power DNS as well, but I've not asked. So if you are running anything non-trivial that needs to, always work, it's always a good idea to run as many different things as possible so that if one falls over, you have another one. It just makes good sense. Of course, FreeBSD does not fall over because, as we know, FreeBSD is perfect in every way. But no, so as you said, the second part of your question, or the first part of your question, FreeBSD and ARM64 are not very well known in this region. I'm here to help, and also there are 2 FreeBSD developers in Iran. Babak is one of them. So if you need local support with FreeBSD, or you want to ask, you are bored with Linux, or you are a victim of systemd, and you want to know if there are nice things in life, I encourage you to talk to...
Also, I vote on Babak because he's a sponsor.
Talk to Babak. He will, he's a consultant, and you can pay him in Iranian money. But do make use of me while I'm here as well.
Let's go, Amin.
Hi,
Yes.
this is Amin Khosrow from Shuttle. Well, it's quite amazing that since it's first introduced ARM64 architecture in iPhone 5, I guess.
Yes.
It's been 2013, I guess. Well, now here in 2018, I'm here and someone is presenting this architecture in Tehran. Well,
It's only 5 years?
Okay. 2 questions. First, how widely it's been deployed into major hardware vendors like HP, Dell, etc. Second, do you have any statistics of the major providers if they're using this architecture, these servers, in their networks for some services, specifically on DN servers, etc.?
All right.
Thank you.
So the first part of your question, I don't think HP or Dell or Lenovo or Supermicro have ARM64 servers. The vendors of ARM64 servers are the Caveums of the world and the Soft Irons of the world. So there's slightly smaller vendors, but that doesn't make them less...
Is there any plan for further deployments? Because it makes
probably.
it very
I
limited.
think, obviously I can't speak for any companies I don't work for, but I would say they would have to be catastrophically stupid if they were not looking at ARM64 for their servers. As far as I know, there are no shipping products from any of the top 3 or top 5 vendors with ARM64 servers, but given the trends globally of power becoming more expensive and the environment becoming more and more scarce, I would expect even the major vendors to start shipping ARM64 boards pretty quickly. The second part of your question, do I know of any deployments running on ARM64 servers in the wild? Yes, I do. I know of 2 companies that are running many ARM64 boards for interesting workloads, not DNS workloads. Unfortunately, I can't tell you what the workload is, but it is largely CPU bound rather than memory bound, or definitely not disk bound. So it is definitely possible to run large non-trivial installations on ARM64.
Well, it would be appreciated if there would be some statistics, so we could easily decide.
If I can find any, I will definitely share them at my next
Thank
opportunity.
Thank you,
very much.
Philippe. Thank you.
Yes, I think we are running half an hour late.
Today we have 3 racy talks, and the first one is about carrier grade NAT, impacts of carrier grade NAT, and browsing. With Ali gives us some detail about it.
Let's see if it's not possible to go ahead. Because there are some animation that we are going to miss it.
Okay. Because
If we do, let's see if it's working.
it'll kill those side screens.
That's fine.
Yeah?
If they can see us.
Yeah. Okay. Yeah.
This is the next one.
That's that way. I've got a PDF if you prefer, but that one.
There are lots of animation. I prefer to have it, otherwise it's not the case.
Yeah.
Cool. Let's save some time. I start to introduce myself. I'm Ali Safari, a PhD student from Politecnico di Torino. We have done this work with collaboration with our colleague in Telefonica and also Paris Telecom. Before I start, I would like to thank Ripe Academy Cooperation Initiative that provided this opportunity to be here to present my work in front of large interested audience. So, the title of the presentation is the impact of Carrigan on web browsing. Basically, I will go fast because we are out of time a bit. So, the traditional NAT is working that the operator provides public IP to the home gateway, and there are different devices. Okay, sorry. There are different devices that gets private IP address inside the house. But in the Carrigan scenario, the operators divide the network in the subnet with the large private IP addresses, and the home gateway gets the private IP address. And in this way, they can save large number of public IP addresses that they have. Yesterday, we had a presentation by Christian that they said that we are out of, let's say, IPv4, and then we have a presentation by Shaheen that they said the transferring and moving to the IPv6, there are some difficulties. So this is the temporary solution that ISP nowadays, as far as I know, in Europe, in mobile and also fixed operators, they are employing. So we are dealing with carrier-grade NAT. By definition, the NATing breaks the end-to-end communication between the host, and the application needs that they need access to the inside the network. They need to do some, let's say, difficulties, to do some traversal techniques to reach to the client in the home. But we focus on the performance application on the web browsing. We just focus on web browsing. We also have done some work on the P2P application, but this presentation that I'm doing today is just on web browsing. And at the end, we will try to just have a look at how much IP address the operator can save by using this kind of NATing techniques. But at the beginning, I mentioned that we don't know anything about the operator setting. We are collecting data from them, but typically the operator doesn't like to share this kind of information, to provide information about their setting. Okay, our methodology roadmap is that we are getting data from real ISP in Italy, that I would say is one of the third great operator in Italy. We have customers that they have public and private IP addresses in the home gateway, and the traffic is monitored on the point of presence that capture traffic from about 17,000 of customers. And we are using some statistical techniques to analyze this data to see if there is any difference between these two set of customers. And if there is a difference, for us it's important to see this difference is significant or not. Definitely there are some difference when you compare two sets, but it's important to understand if this difference impact the user or not. So we are considering just web traffic in this presentation. The monitoring scenario is that we have, as I mentioned before, we have customers with private IP address, we have customers with public IP address, so we have two distinct sets. We have a point of presence in the ISP network. The traffic for the one that has a private IP passing through the CGN, the one with the public IP is routed directly to the internet. And we are using a T-stat passive probe, which is a probe that is developed in our group in Politecnico Torino, that is fairly scalable. It's not CPU hungry, and you can use it with a, let's say, high bandwidth link. We are using in Politecnico for 5 years, and nowadays it's supporting 20 gigabit per second link. And the data set that we have in this work, it's a 1 month of data. We have more than 17,000 households in our data set. 40% of them as a public IP address. We have 1 billion of TCP flows, less than 1 billion for HTTP requests in these data sets. Here I'm just showing how the T-stat compute the statistics of the flows, what we call it flows. Here is just an example of TCP. For instance, when you do a TCP handshake, you have a SYN, SYNAC, and ACK as usual. So you have two time steps. The probe in the middle see the time that you send the SYN and the time you receive the SYNAC. For each segment that you send and receive, which is segment and corresponding acknowledgement, it computes a round trip time, and that at the end, it doesn't save all the round trip time. It just saves average, maximum, minimum, some statistics about it. And it computes the three-way handshake that at the beginning, we assume that because if you start a connection, you have to pass through the NAT for the first time, maybe open a session, maybe it would be different. Then you send the GET and receive the data itself. So we define another metric, which is time to first byte, which is the time that elapsed between you send the GET and you receive the first packet of the data from the server. In this way, we define 9 performance metrics. We consider 9 of them. And we compute the probability distribution for private client, the client that has a private IP and the client has a public IP address. And we use Jensen-Shannon divergence to quantify the difference between these two distributions. For sure, there are many of these distance metrics that exist. And the paper, if you're interested, you can check. We can discuss offline. There are many of them. We chose this one, first of all, because it's well-known. Otherwise, it has 2 basic properties that for us was really important. First of all, it's symmetric. It doesn't matter that you compare X with Y or Y with X, because we don't know which is the baseline for us. And it gives us a bounded value. This bounded value helps us to quantify the difference. Here is just the mathematical part. I just go fast, but the message here is that we get a bounded value. We can define it one threshold and say that, OK, above this threshold, there is a difference. Less this threshold, there is no difference. But we define 2 thresholds. If there is less than threshold, we say there isn't significant difference. For sure, there is a difference, but it's not significant. If there is between these 2 thresholds that we define, it's, let's say, noticeable. If it's larger, there's a significant difference. So we can dig more and understand what is the problem. As usual, if you deal with the statistical analysis, you have to check that your data is not biased. So we have done lots of filter to get rid of the connection, which is short. The data is the one that they're transferring the real data, and so on and so forth. When you compute the distribution, you have to make sure that the bin size that you are using is meaningful. If you compute the round trip time and you choose the bin size 1 millisecond, you go to too much detail. And the population size is really important. As I mentioned, there are 2 or 3 pages that we describe, and we try to justify our choices. But the main message here, I would say that we have large data sets, so we assume that we don't bias with the population size. The performance metrics, I guess I'm going fast. I think you're waiting for the coffee. So. Performance metrics. The first one that I would like to present here is that three-way handshake. At the beginning of the work, we assumed that in this metric, we should see the difference for these 2 sets. Here, we just divided all the traffic, web traffic, HTTP and HTTPS, and all this web traffic that we have, in 2 sets. We don't care about the service that they are using, and we create, in the y-axis, you can see the CDF, actually empirical commutative distribution function, and the three-way handshake in the x-axis. In the figure, we can see that there isn't a huge difference. Yes, these distributions are different, but not the same. But then we focus on some specific application. For instance, we consider the iTunes contents that comes from the Akamai, in our case, and Google search. So we have seen that all of the distribution for them are different, but the private and public IP address, the client with them, doesn't see any difference. Doesn't see significant difference based on the JS value that we get, because we define the JS value to quantify this metrics. We have done the same for the download throughput, and we do the same. Again, JS value tell us it's not significant. But when we see the other metrics, which is the number of hops, we see that when we consider the number of hops, we can see that the one that the client, the customer that has a private IP address, passing inside the operator network over a couple of more hops. But what we have seen, these longer paths, either well supported or the configuration of the CGN, it's, let's say, appropriate, we didn't see huge impact on the other metrics that we consider. Okay, if I want to present the summary of our finding, we consider these metrics, number of hop, round trip time, and throughput, number of scenes, because we thought maybe it can create some, at the beginning of the connection, it creates some problems. So you can see the threshold that we have here for the significant, noticeable, and negligible. As I present a few samples before, all the metrics, except the number of hops, they are, I can say it was negligible difference, but the number of hops has a let's say significant difference. So the main message that in our data set is that there is no significant impact. But I would like to emphasize that we don't say that Carrigan doesn't have significant impact. Maybe it depends on the configuration or the networks. But in our data set, what we have found is that we haven't seen significant impact. So what we try to, let's say, understand is that, okay, the operator provides public IP to the customers. How many of these customers are really use the reachability of this IP address? Maybe some of them actually running a service. We have seen that some small business that they are running some server there. For this analysis, we considered the IPs that receiving connection from outside. What I mean receiving, that the scene started from the outside of the network, not inside the ISP. So we considered some well-known protocols like HTTP, IMAP, POP for the mailing, and so on and so forth. In this plot, you can see that we have number of active servers in the y-axis, and for each day, at each hour, we compute the number of active servers. That you can see the number of active servers is less than 25 at each hour. But if we compute the cumulative number of the whole IP, public IP address that we have seen in our data set, we can see that it's less than 16, which is only 6% of the customers, less than 1% actually of the customers running a server at home. So the ISP can change the contract and ask them, okay, if you really want it, use it. Otherwise, we can provide a private IP for you. The other things that actually is just kind of naive analysis to understand, okay, how much the ISP can save by providing, the number of public IP that it has, to save by using this technology. Let's assume that the CGN just do the netting itself, just do the network translation. So if you have 17,000 customers, if all of them are active at the same time, you need 17,000 public IP to serve them. But what we have seen is that we consider an idle time of 5 minutes. It means that if the connection is not active in 5 minutes, the public IPs get back to the pool and CGN can reuse this IP address again. So we compute at every hour in 3 different days, weekdays and weekends, because typically they have different patterns in the data sets. And we have seen that in maximum, we have 7,000 concurrent active public IP address, which can be translated into 60% of saving. But as we know, that they can do also port address translation to save more. Well, in this way, we compute the number of active ports in the last 5 minutes. So each client has, maybe one client in 5 minutes has 1,000 of ports open. So we call it, we compute it, for instance, 1,000. We compute the distribution, and we have seen that in the blue line here, that the y-axis shows the number of active ports over the time. The blue line shows the maximum, and the green line shows the 99th percentile of the distribution. We have seen that it's less than 2,400. It means that they can use the same range of port, all available port numbers can be used for 25 more times the number of clients that they have. And if I go to the conclusion, in the large-scale passive measurement that we have done, we consider multiple performance metrics, and we just consider web browsing, and in our future work, we consider also P2P applications. And we use one of the, let's say, one of the popular distance metrics to pinpoint the relevance of the difference. Because if someone gives you, okay, the difference is one value, for you maybe it's hard to interpret. But in this way, you can get a value which is meaningful. So we can see that in our network, we cannot see, let's say, no harm. There isn't significant difference for them. And as I mentioned, we wanted to see how they can really dimension this CGN. How much public IP and port number is public IP is needed to serve the clients to be compliant with this agreement that they have with the customer. And implication of on the P2P that actually is done is just not presented in the work to get rid of more detail. If you have any question, I would be happy to reply. Before I finish, I would like to say that in our group, we are doing lots of research on the traffic measurement, that we are happy to collaborate with you if you want to do passive measurement. If you already have the data, if you want to analyze it, we have, let's say, a large cluster that we are lots of students, 10 PhD, a couple of postdocs. We are happy to collaborate with you. If you like, we can chat offline.
Thank you. Very interesting topic. And any questions? Hopefully, no. And
they want to take a coffee.
Yeah. We have 15 minutes for coffee break. So we start in 11:40.